Hi, so I'm, as Yang just introduced me, I'm Mark Puddick from Pivotal. I've come here today, I've actually worked for Pivotal in Australia, in Sydney, so come a fair way to do this talk. I'm going to talk about GPU machine learning from laptop to cloud. So we're going to have a few demos in this as well. And we're just going to go through basically a workflow from getting a simple model and getting it running in the cloud and some of the nuances around that. Okay, so there's a few things we're going to just cover off. As I said, we're going to do what and why. So this talk came from a customer that I was dealing with. They had a large bare metal analytics cluster that they were using, and they wanted to actually put that into Kubernetes. And also some stuff that I was doing, some machine learning stuff that I was doing in my own time. And I was kind of wondering how easy it would be to take some sort of workloads that I'd been running mainly on my laptop and run them on the cloud, and seeing if we could scale them out a little bit more. So we'll go through a quick bit about how to get your laptop, dev laptop up and running, because we want to, the other thing around this is it's kind of based as well about kind of workflow as well, if you were going to do some CI/CD around this as well. So we'll quickly go through how you get a laptop up and running. We'll do a couple of demos around that, and then we'll talk about what happens when we move that to cloud and what's different. And then at the end, we'll get the conclusion. We might have some time for questions. I'm not sure how much time we'll actually have. When I ran through this, it did take about the time this session is, so we might not have much time for questions, but I will be on the Pivotal booth tomorrow morning, and you're welcome to come and talk to me anytime in the conference after here. Okay. So the first thing I said, we were going to get started on a laptop. This is going to cover off using Keras, so I don't know if anyone's familiar with how familiar people are with things like Keras. So it's going to cover Keras, TensorFlow, and Python. We're going to talk about how we Dockerize. We're going to get that running in MiniChip locally with GPU acceleration as well. And then we're going to push it up to the cloud and run it in the cloud and run that with some GPU acceleration. I'm not going to cover off Jupyter Notebooks. You can also use Jupyter Notebooks. I think the TensorFlow GPU Docker image has that built in. I didn't want to do that because I wanted to be able to put this eventually into a kind of CI/CD pipeline and demonstrate that side of stuff as well. Okay. Can't see my speaker notes. Okay, so to get your laptop set, I was originally going to go through kind of a laptop install, but then I realized it's going to be different for everyone, and B, it's going to be kind of painful and take a long time, so it's probably not super valuable. So I'm just going to summarize what you need to do to get that up and running. So you need to get the NVIDIA drivers installed. This is pretty obvious stuff, right? So those NVIDIA drivers, there's proprietary and open source ones. I think I'm currently using the proprietary ones, but you can actually use either of them, and they both work. There are some challenges around that, getting them running. Mainly secure boot seems to cause a lot of problems as well when you start to put the CUDA toolkit and the CUDNN stuff in, which you'll also need to do. I'd probably just go through the TensorFlow actual instructions for installing those, because it's the simplest way to do it. And again, going through it in this session would probably be a bit of a waste of everyone's time. And then eventually, once you've got all that up and running, and you can check it, there's a few ways to check it with things like NVIDIA, SMI, and a few things like that. Then you can install the TensorFlow GPU, and you can just do that through pip and Python. Okay, so that's basically how you get your laptop set up. So as I say, I wanted to do that quite quickly. This is just to run normally without Dockerizing, without putting in MiniChip or anything like that. So one of the things that you probably find when you do this is you'll have a lot of version conflicts and things like that. There's not really much advice I can give you apart from you'll just have to kind of work through it. It can be a little bit laborious. And I say secure boot generally causes a few problems as well. So personally for this laptop, I have secure boot off at the moment because I only use it for this, so I'm not too fussed about having it on. Okay, so we'll do a quick example, and we'll go through a little bit of code quickly just to show you what I'm going to do as an example today, and we'll run through how we move that across the different environments. Okay, so give me a minute. So we're going to run a really simple model. So I think if I do that, just give us a sec. Right, so we're going to run a really simple model. Oh, that's really big. I made this bigger earlier, but it's actually way too big, so let's scale that down. hopefully better. How's that? Oh, it's still pretty bad. Okay, well, we might be able to go through that quickly. So you, actually, no, we won't. We'll put that across. Just a second. Decrease. Okay, this is going to be better, I reckon. All right, a little bit more readable, right? So this is just imports and stuff. This is really simple. This is just a really, really simple model. We load some data up. It's actually in a CSV file. There's not a huge amount of data. We've got it's a cut down kind of VGG16. It's just doing some image recognition. And what it's actually going to do is load up a bunch of pictures of Lego bricks. There's 8 different Lego bricks, and it's trying to detect which one. So I thought this would make quite a good demo. This was something I did ages ago because we were trying to categorize some Lego for my kids, which I won't go into in this. So you can see it's really simple. There's just a train model. It's got the optimizer there. And then we just fit it, and it's going to output it. So we'll run it up quickly, and you can just see what it does. I'm only going to run this for like 3 epochs, so it's not going to do much, just so that we can run it quickly in the demo. So, just so you can see what's going on. Actually. So the idea behind this, okay, that's going to be really big, but we'll live with that one. Okay. I've made a typo. Oh, it's really big. Let me. So you can see you're going to have some really big machine learning here. Control plus. There we go. It's a little bit better. So it's just going to run through. It will run. It's going to use the GPU for this, so it's going to run a lot quicker. Generally, you'll find it's about 10 to 20 times quicker, I reckon, when you run it from just pure CPU on this machine. So that's going to run through. It's only going to run through epochs, and you'll see that. I'll go back to the slides. So it's going to probably. I think this model's a bit rubbish, so it's probably not going to be super accurate. 75. So there we go. All right. So that's that one. Let's just go back to the slides a little bit. Okay, so we've run that. So what we're actually going to do now is we're just going to Dockerize that up. I have 2 Docker ways we Dockerize this. I'm not going to show you Dockerizing it because that will be kind of boring. I'm using the NVIDIA route rather than the TensorFlow route. You can, all this isn't going to share all this, but you're welcome to take pictures or whatever. And then we just basically install Python and install some dependencies. And that's just going to create our base image. And then our actually code that we're going to run, we're going to do a separate Docker file for that to run on top of it, right? So that when we do our builds, we're not actually downloading a ton of stuff every time, because this is probably downloads, I think, about 2 gig or something when it actually runs up. So there's just a requirements text file and a Docker file for this, so it's pretty simple. Once that's run, we'll create our base ML image, and then we just use this to actually then pull that out, and then use our Python file that we've already built, and then we can run that up. So, just think. So we can quickly show up. So once we've Dockerized that, then what we can do is we need to run up Docker with the NVIDIA runtime. So you'll have to firstly install that NVIDIA runtime for Docker to get it to run. And once you've done that, then you can run it up. That's just an example run there for running the NVIDIA SMI, so you can check that it's working. I also would recommend, and you'll need this for MiniChip, to put that as your default, the way we're going to run MiniChip in this demo, to put that as your default in your Docker daemon file, which is in etc Docker. So easiest way to do that. Okay. So once we're also going to mount a local directory, because we're going to read our data from disk, and I'll explain a little bit more about that, how we're going to run that as we go. So we'll build an image, and then we'll run it. So we'll run it quickly. We'll see if we can get it to run Docker now. And there's just, the reason to just do this is to just make sure you've got everything set up beforehand. Otherwise, you can have some problems when you go to run MiniCube. So let's run this up. Have I got that? There we go. Hopefully my demo will work. So we're just going to run it up now in Docker. Okay. So run Docker, and it's just going to output it. So it's going to see the same sort of thing. It'll scroll it out. So we'll start that off, and we won't sit and watch it for the whole few minutes. But we'll just see if it starts up and checks that it'll load. Should do. Okay, so it's running now within the Docker container, right? So we've Dockerized that, we've got that running, so that's cool. We'll move that one out of the way. Well, that's running, I'll just let that run through. Okay. So the next thing we kind of want to do with this is we want to run it in MiniCube. So we've got a couple of options for MiniCube. When we set up MiniCube to run with GPU, it's a little bit fiddly to get it working, to be honest with you, but you can get it working. There's KVM2 driver. You can run it with the KVM2 driver. You need to have, I think, IO MMU enabled on wherever you're running it for that to work. However, I think you can dedicate more of the GPU to it, so you can have less memory issues around the GPU if you were going to do that. But what's actually a lot simpler is just to run it with VM driver of none, and then it'll basically fall through to the underlying Docker. I think you need to install the plugin once you've done that as well, and that'll get that up and running. So I've got this, I've got a MiniCube up and running with that. So what we'll do in a minute is we'll have a look at what we've done from a spec to get that up and running. Well, here we go, straight away. So there's a couple of things here. We've got persistent volume. We'll have a persistent volume and a persistent volume claim for the data. So we're going to bring the data in just from disk effectively, as we had done before. And there's some pros and cons of doing that, which I'll talk about in a minute. And then we are going to run through a job. So rather than run just a deployment, we're going to run a Kubernetes job because we want to run this. It's going to run and exit out. So we want it to run and finish, right? It's not going to continually run forever. A couple of things in there that we have to have in there. We have to have resource limits GPU 1 to say that we need to use the GPU. Otherwise, it won't schedule. It potentially won't schedule onto pod with GPU enabled. Couple of things there in MiniCube. The resource limits don't seem to they don't seem to work particularly well for GPU. So if you run up more than one, you'll probably have issues. Because Keras will actually, and TensorFlow will actually just try and use all of it. You could potentially cut down, say only use half the GPU for Keras, but probably not really a huge amount of gain in doing that. So, let me have a look. So we'll go and have a quick demo of that one as well. So, let me just get to the right directory. So we'll go over here. Okay, so we're going to use our MiniCube context. My MiniCube at the moment has some issues with its certificates. So we are going to have to run it insecure, which is kind of not ideal. But this morning when I reinstalled everything, it seemed to lose the certificate somehow. And I wasn't able to fix it in time for the demo. That should be okay for the demo. So we'll just have a look, see if there's anything running. Just double check I didn't leave anything. So we've got nothing running from the jobs, right? So if I have a look, I have a jobs MK file here, which is the whole job spec. So on again, I'm going to share all this, so you're welcome to, you can be able to download it afterwards. So this has got all the stuff in here. It's got labels, it's got, say, the NVIDIA. We also have a bunch of environment variables, which I'll talk about in a little bit. And we have a bunch of other stuff at the bottom. We've got the volume claim, but let's do that. Okay, there we go. So you can see how we've also got the persistent volume claim. So I've set the volume claim up separately, the persistent volume and the claim up separately. So, okay. So let's see if we can get that running. Okay. Oh, happened here? Oh, let me see. I think there must be a space in there. So it's created our job. Let's have a look at that, see if it's running. Sorry, I have to keep looking around. I haven't got this mirrored, so. Got a job there, and hopefully this is working. Okay, so we've got it running. So if we have a look at the log for that, again, we should see it again. So once we've got that. Okay, so you can see it running there as well, so that's cool. So we've now got it containerized, we've got a job definition for it, and we've got it all up and running, so that's great. So what we want to do now is move it to the cloud, so let's just talk about that quickly. So we can just move this, drop our container onto the Kubernetes cluster and run it now. Well, we kind of can and can't, right? So there's a few things that's going to cause potentially a few issues here. Firstly, all of the previous demos, they're loading from the local disk. So we're going to have to mount the disk somehow if we're going to use disk, but we may not want to use disk. We send it into standard out or output, which is kind of fine, not too unhappy with that. And the graphs that we would display locally, often we're using PyPlot for, which obviously we can't use if we run it in a cloud remote. So, so we need to want to make it a little bit more cloud native. And it'd be nice to be able to, when we run it in cloud, to be able to spin up multiple things so we could do some hyperparameter tuning and that kind of stuff. Okay, so we can get our data. I had a look at various ways of bringing data in. We can use object stores, databases, disk. For this demo, we're just going to use disk. And what we're going to actually have a master or orchestrator that's going to download the data. And that's going to have a read-only for the other nodes in the cluster that are going to read the data. So we're just going to read it pretty much the same as we have done before. So we are going to do a persistent volume. There's going to be one pod that will effectively read that data from a remote location and store it. And then the other pods will have a read-only claim on that so they can read it and run it. So the other option would be to, other kind of options you could do is pull the data every time you run up. That's probably not the best of ideas. It's probably going to be slow. Every time you start up, you're actually downloading the data. It's probably going to be more. You could pull it from S3 or something like that. Obviously, if you're going to distribute and do just more distributed machine learning, becomes kind of a different game, and you want to probably then you're probably going to read from different places again, maybe more distributed file system or distributed cluster systems. Okay, so what we're going to do is we're going to have an orchestrator that's just going to run that through. It's going to write that to the storage that's going to read it off. Okay, so I've got a little Go app to do that, and it's really simple. So we'll just have a quick look at that. Oh, wrong one. So let's have a look at that. So this one here, we're just going to go through it. It's going to do a bunch of stuff. So there's as we go through. So it's going to run through, and we're just going to download, check to see if the files exist, and then download it. Right. So it's really simple. So we run that. We're going to run that out as a pod on our in its own pod. So we'll show this in a minute, I think, because the time's looking a bit tight. Okay, so we basically deploy that just as that's deployed as a deployment, because it's going to be continually running. It just checks every time you start something, it checks to see whether it needs to download the data. We'll download the data and then store it into the storage. And the reason it continually runs is it's also running a web server on there, and because what we also want to do with that orchestrator is we want to get our graphs out from, so we can see graphs and things from the data that so as we train in, we can actually see what's going on. So we want to be able to see some graphs like this as we come through, and you can see my training models probably aren't very good in that one. So what we're going to do is Keras callbacks, so we need to have an endpoint. So again, our Go app's going to have an endpoint to take those callbacks, and then it's going to store those locally, and then we'll display the graphs. So you're going to see this like that. So let's see if we can get this. Well, we'll show you, I think I'll show you that in a minute. We'll do one more thing. This is one more thing it's going to do. So what we're going to do is run this. So we'll run it. We'll run that up now, and I'll show you the job what's running. So I'm just going to change my cluster. So I'm now going to switch to the cluster. It doesn't really matter where the cluster is. It just needs to have GPU enabled. So you probably will also have to install on your cluster a plugin to enable the GPU within Kubernetes as well. Oh, wrong one. So just give me a second. So I'm going to switch this over to GCP cluster. Oh, that's really big. So we'll go over here. Oh, look at that. So we've got that running there. So if we go and have a look, I think I'm already running the orchestrator on there. So if we do a control, okay, pods, we should be able to see that we've got that running, hopefully. Yep, cool, so that's running. So if we now get another browser window up, we can have a look to see what that looks like. So let me just escape that. And that'll be the one right there. So again, bit big. So you can see there's nothing in there at the moment, but that's just our output. So we'll run up a job now quickly, and we should see that come through, right? Okay. So let's apply. So we've got our job.yaml file, which we can look at on. So let's just have a look at the job.yaml file while that's running. It's pretty much the same as the other one. Not a huge amount of difference in it. It's on the back there. And you can see it's just going to pull, the only difference is it's going to pull the image from there rather than the local one, and it's going to always pull, yeah? Because we always want to pull it when we've got some bits and pieces in there. Okay, so let's go back to our terminal and see if we can see if that's running. Should be that one. Not that one. Right, so we can do that one. So let's have a look what we got in jobs. Okay, so we got that one job. And that's running. So again, we can go and have a look at the logs around that. Let's just type it. Okay, so we can see that running. If we go back to our web page now, we should be getting the graphs through. So let's have a look at that. Can we refresh this? Oh, hang on. There we go. Okay, so we can see that the learning stuff's come through, so we can see our accuracy and our cross-validation. Cool, so the last thing that we want to do with this, we're kind of done, is we want to okay, so the last thing we want to do is we want to tune some hyperparameters. So instead of using the batch the actual batch YAML here, we're actually going to codify this. So I've got this in some Go code, and we can pass in, we've just got a little API endpoint that we can send some stuff to and get it to run. So it's going to run up a bunch of jobs. So I'll show you that quickly, what that looks like. It's going to look in there. So if we here, we've got the job builder. Oh, let's move it back there. We've got this job builder here, which is basically just codified that YAML file, right? So we can see that YAML file, and we can send some simple piece of JSON to that to get it to run a bunch of things with the different parameters. So if we go to here, you'll see I've got we've got this test run JSON, and it's just going to have the high-level stuff and then a bunch of values that it's going to run through. So we'll run that through from the command line, and that should run through. So I've got a little script to run actually, which is that multi-job. Okay, so once this is running, you can see the jobs will spin up. So we can see if we look at the pods now, you'll see that there's basically 4 jobs run up for each of those different things that it's going to run. I've only actually got 1 GPU node running, so it's going to actually just queue them up. So that'll run through. It'll probably take a little bit to run through. So, but you'll see, I'll show you the graph in a minute, and we'll let it run for a bit. Okay. So if we go back to here, and go back to ML data, refresh this. You'll see there's a couple of things here. So we're starting to get our second trace on there, so the other model that's running. The other thing here is we've got the weights from the previous model that we've trained, so we can download that now and we can run it as a test. Okay, so this is going to take a little bit to run because I didn't spin up another node, which I should have before I started, but we'll let it run for a little bit. But while we're doing that, I've got the model which I trained earlier. We can run down and we can see if it works. So I don't know if it'll work in this light, but we'll try. So I've got a little webcam here and a piece of Lego somewhere. Just give me a minute. Okay. So it's running. All right. Well, we'll see if we can see if we can detect this as Lego. I'm not sure what number this is because I can't find the normal one I would do. And it's a little bit dark, so I'm not sure if this is going to work. Okay, so we've got the weights downloaded there somewhere. Their last run H5. So we'll run Python. Get image. It's text cam. And there's actually a little view here, which we can see what we're doing. So we point that at our Lego if we can. Let's try and get it. It's the same, I'm not sure. Let's see if it will detect it. Okay, so it said it's number 4, which I believe is correct. Let's have a quick look at the training data. And we'll see if that's worked. So number 4, yeah, so that one there. So I think it got it, did it get it right? No, I don't think it did. I think it was actually number 1. So it actually got it wrong, but it was, at least we tried. I think it's probably the light here. Okay, so if we go back now, we can have a quick look at the presentation. we'll have a quick look to see if our graphs have updated a bit more. We've probably got a bit more data on there, but probably not that interesting. Okay. All right. So we do, as I say, we can just post that JSON in. I actually ran a script to do that, and that's ran up, so you can see that's all running. So we run the multiple versions. As I say, there was a little few tricks I had to do when I was running this locally in MiniChip to stop it over consuming the GPUs. So we've got our results out, and we've got our weight stored on disk. So that's pretty much the end, because I think I've got about 3 minutes left. So a couple of things we can do with that which we didn't really show, which is simple enough to do. We can actually increase the data size now. We're running in cloud pretty easily. We could also parallelize the TensorFlow jobs if we wanted, so we could actually run it in parallel, so we could have one big job that would run in parallel. The good question is it worth containerizing? Someone was talking to me about this, and they said, shouldn't we just run all this in bare metal? And it kind of depends on the workload you're running. I think in some cases, if there's plenty of other ways to do machine learning, there's obviously cloud machine learning tools that are there. This is kind of a nice way, I think, to do it, just if you want to put it in a CI/CD pipeline, you don't have massive jobs. You can get the downloads from my GitHub. I think it needs updated, so I will update it this afternoon. So I think I've got about 2 minutes left, so if you've got any questions, probably not time now. But you can grab me afterwards, or feel free to come down the Pivotal booth tomorrow morning, which I'll be there. Thank you very much.